is just going to give an introduction about cadCAD, which is the tool that we're discussing today. And he's a research engineer from Block.Science.
Hello, everyone. My name is Markus. I'm a systems control engineer based in Brazil. I work at Block.Science, doing some working on internal research, some client projects. And for the past year or so, I've been closely involved with developing cadCAD, acting as sort of a subject matter expert and working with the developer, Joshua Jodesty, on developing the package. So cadCAD, the short answer is that cadCAD is a Python package targeted at modeling and simulating complex systems, right? So the idea is that once you have a model of your system described in a way that cadCAD the way that cadCAD expects it to be described in, you can do Monte Carlo simulations, A/B testing, parameter sweeping, of the system in order to understand how it responds to different assumptions, right? Be it assumptions regarding the user behavior or parameterization or internal policies of the system, anything you want. It's general enough that it can cover a set of basically any different industries, but it has mostly been used in the crypto space by projects that became familiar with it during the beta period, because it's the kind of field that leads to complex systems often, right? Because of the economies involved and the openness of the systems. So that's the not so short answer to what is cadCAD. We'll dig deeper into during the AMA.
Awesome, thanks so much, Markus. Cool. So I'm a software engineer from Molecule and Linum Labs. Linum Labs is developing a lot of the software for Molecule at the moment. And so what exactly is Molecule? So at the moment in the pharmaceutical industry, the pharmaceutical R&D process is very costly. It's not very efficient, and it happens behind closed doors. So your big sort of monopoly pharmaceutical companies take on a lot of risk, and a lot of the times the success rate is very low, and your incentives for developing drugs are mainly profit driven, which is also something that, the common stack is sort of aiming to work on. And so what we're doing with Molecule, with the Molecule Catalyst, which is what the sort of initial launch of our project is, we're creating a crowdfunding, open collaboration and data sharing platform. So we're trying to move traditional IP developments and pharmaceutical innovation from sort of siloed pipelines to a more open R&D marketplace and ecosystem. And this is kind of where complex systems comes into it, because we're moving from what was a stale linear system to a more dynamic complex system. And we need to apply more rigorous system design and modeling because of that. So we've got a page called catalyst.molecule.to, which you can go to sign up to find more updates. We're going to be launching in roughly about a month, I think towards November. We've got the initial web app up and running with all the contracts and the modeling we performed. And here you can see a few screenshots from the app. So yeah, looking forward to launching that soon. Cool, we're going to move on to the AMA. So we've been collecting questions from Twitter and the Google form. You're welcome to stop us and ask questions as we go, but there are quite a few questions, so maybe better to leave discussions for the end. So here's the first question, which Markus is going to start with.
Cool. So I'm going to go ahead and answer that question along with the next one. So I'm just going to read this one before we move on. What are the steps required to go from an idea of a governance system to modeling and simulating it in cadCAD? And then the next question, which sort of has a similar answer, is if I intend to use a triple bottom line to measure organizational performance, can this be simulated using cadCAD? And the short answer to both questions is yes, both of those things can be simulated using cadCAD. And the process for that is basically the same in both cases. You have to start by describing your system in a way that it can be modeled, right? So we start every process, every project like this, we start by establishing what the system requirements are, and then sort of translating that description, those system requirements that are described in natural language, translating that into mathematical models that can then be implemented in cadCAD. So we like to use some diagramming language that we came up with. If we can move to the next slide, please. We have an example there. Oops, sorry. I thought I had it there. Well, it's okay. I'll post it to the notes. Basically, what we do is we have this this diagramming language where we start modeling what are the state variables of the system, and what are the mechanisms through which external agents of the system can interact with the system in order to, and which will result in updating those state variables, right? So be it we're talking, even if we're talking, it doesn't matter if we're talking about governance or we're talking about triple bottom lines. It all boils down to what are the state variables that represent those things that we care about in the system, and how do those things evolve in time? What makes those things change, right? So if we're talking about governance, we might be thinking about something like conviction voting or other voting mechanisms, and there is sort of this interface between the system and the users that allows the users or these external agents to interact with that system, right? And then from there we start collecting some key performance indicators on those, based on the state variables of that system, in order to be able to compare different simulations of the same let's say system with slight variations, right? So if we're doing an A/B testing or parameter sweeping, we're often not interested in in the actual history of each one of the state variables, but some composed indicator that will help us compare those two variations that we're working with.
Awesome. Yeah, Marcus, I think those slides didn't refresh in time, but we can show it after the discussion maybe.
Yeah, sure, that's fine.
Perfect. Cool. So the next question that came in was, what is the process for going from a stock and flow diagram to a differential specification to a cadCAD model? And yeah, I had to kind of go and Google what a stock and flow diagram actually is. But yeah, basically it's the idea that you've got stocks and flows, where stock is a measurement of at one specific time, and it represents the quantity existing at that point in time. And a flow variable is measured over an interval of time. So in this sort of diagram at the top, stock would be maybe the initial sort of hatch phase collateral that you start with in your system, and the flow would be the flow of additional collateral after your maybe augmented bonding curve system starts. At least that's what I think. So in answer to how we set the boundary of our models, so basically by performing things like Monte Carlo simulations and parameter sweeps, these boundaries will sort of become more apparent. And I think, you know, before you start modeling something in cadCAD, it would probably be lying if we said we know exactly what the boundaries of our system are. But modeling is a way to give you a much better idea of what the best and worst case scenarios are and what those boundaries of your system look like. So you should basically try and start simply by parameterizing your stock, and you basically do this based on business knowledge and assumptions. So these are things that you, as an expert in your product or field, kind of assume. So maybe some of the sort of starting parameters. Then you try and look at who your actors in the system are and the actors that you care about in the system. So these are people interacting with your system, maybe different components within the system, and any external influences as well. Then you take your flow diagram relationships and see if you can represent them maybe as a network X graph, if that makes sense. So often these diagrams can be pretty well represented in that way. And then you can slowly start drilling down and simplify the relationships to sort of step-by-step logic, where as you go along, you have a more simplified relationship. And yeah, I mean, often the system itself is complex, but each of the components won't necessarily be. And then you use your policies as the glue and driving processes. I think the next question is for Markus. And also, I think, Markus, if you have anything to add to this, obviously go ahead.
No, that was great. We can move forward.
Cool.
If anybody's confused, the diagrams that we make often that you'll see on like the community.cadcad.org, they have diamonds in place of flows. And I put some note in the chat, but basically I've been like abusing the notation from the traditional dynamic systems, sort of Sturman style stock and flow diagrams like we showed in the slide, by sort of trying to shift the focus away from passive flow in the direction of active sort of state transitions as a result of agents using mechanisms. So if you find it a bit confusing, what I generally advocate is learn the syntax that's sort of the textbook syntax, like what we saw in the slide. But then once you understand that, you can easily, I think, see why and how we've mutated it. And in the future, I'll be writing something up about it. It's just a little bit of a bottleneck. This is Z, by the way. So sorry to interrupt. Continue.
Awesome. Thanks, Michael.
Good to see you made it, Zargam. Do you want to give a quick intro for the people watching the recording afterwards?
Sure. I'm Zargam. I founded Block.Science. I ramble about math things, and then really smart people turned them into software so that we could make more math things. Yay.
Cool. So the next question is, how can mechanism design be applied outside of direct currency systems? Things like exchange, token curator registries, and auctions are all brittle when completely permissionless and trustless. Can we use cadCAD to find a balance that prevents cheaters from manipulating this important DeFi fixtures? The answer is, I think it's yes. cadCAD definitely can help with that. Again, it comes down to modeling, designing the mechanisms, establishing the parameters, and especially making user assumptions in this case, right? So cadCAD is not like the silver bullet that's going to give you the answers to your problems. It's going to help you understand how your assumptions affect the decisions that you're making. So if we're never going to predict how a system is going to behave using cadCAD, what we're seeing is under a set of different assumptions regarding user behaviors and internal system design, how would the system behave, right? If we encode manipulating behavior in the user behaviors of our system model, then we can start designing mechanisms in the system that prevent that kind of manipulation. But they will only be as resilient as we encode them, right? As we program them to be. If we program naive manipulation models, then we will encode naive counter mechanisms in the system, and they might not be representative of the actual manipulating behaviors that we will see in real life once those systems are deployed. Then again, we have some historical data that we can rely on when modeling these user behaviors. We have a lot of economic literature and systems engineering literature in the background to help us design that. But again, it all comes down to how well you model the system and how much sort of this trade-off between digging deeper and building a more accurate model, or staying on a level that's enough for you to make the decisions that you're making.
Awesome. Thanks, Marcus. So just a quick point on this next one about complex systems. I'm going to post a link in the chat that is a good course on an introduction to complexity, and they have a really good summary of this in there too. So Marcus, you can go ahead.
So the question is, at what point does a system become a complex system that needs to be properly modeled and simulated? And then I would argue that if you zoom in enough, any system can be understood as a complex system, right? You can think of it as a complex system. And if I'm dropping a hammer on the floor, it's pretty basic, like high school physics. But if I'm interested in understanding how each one of the atoms in this process moved, and how each one of the atoms there were impacted, maybe this becomes a much more complex thing that we would like to understand in more detail. And I think it also relates to a previous question that Ben answered regarding the boundaries of the system. So if we're thinking about the system as sort of a more self-contained thing that doesn't, we sort of treat everything else as everything else outside of that as a black box, and we don't care much about that. We just treat those as inputs and outputs of the system. It also becomes a simpler thing if we start modeling different user behaviors, different agents that interact with the system. It starts becoming more complex because it starts becoming more difficult to immediately understand how each one of those components will interact with each other, and what outcome, what kind of impact they will have on the ultimate outcome of the larger, broader system.
Awesome. Thanks for this, Marcus. Okay, next one. How do you decide whether to treat, or this is exactly what Marcus was talking about now, whether to treat a component as a black box or dig in and properly parameterize it? And I think this is a problem that sort of beginners to cadCAD need to tackle. So in the diagram there, you've got a sort of graph, which could be a complex social network. And, you know, to model your system, you can dig in and properly parameterize it, or you could treat that same sort of growth in a social network of people interacting with your system as a sigmoid curve, and both of them, you know, one is more complex than the other. So the idea is to make your components as simple as they can be to properly represent the system and reach decisions you need to make. And so usually in a complex system, the individual actors are not necessarily complex themselves. But also, if you don't fully understand a component of a system, sometimes it's easier or better to recognize that and abstract away from it than to try to make too many assumptions about the behavior of the component. And what I found doing some of the basic modeling of Molecule is that you can often tell a lot from the variance or sensitivity to parameter, especially in a black box system, where the system is maybe too complex to model entirely or accurately. So instead, you can look at the best and worst case scenarios. Yeah, obviously, we don't all have the mathematical or engineering background necessarily to properly mathematically model a component, but you can often make some basic assumptions about the components that enable you to treat it as a black box.
I would.
Can I throw a thought in?
Go for it.
Oh, thanks, Benjamin. Yes, Marcus and Benjamin, I totally agree with you. And the way I think about it is that, yes, all systems are complex. What we're used to doing is just basically filtering out information and interactions to the point that we know we have not up to this time been really looking at complex systems because we've been turning them into linear systems. The complexity arises, you know, primarily at the interactions, right? So if you spend a lot of time looking at how the interactions between state changes, actors, all different parameters change and evolve, that's where your complexity is going to be.
Yep, I agree.
I'm gonna throw in a point I think that might help people too, is that it's important to be clear about what question you're trying to answer. So every model is a perspective on a problem rather than a sort of, you know, perfect representation. There's like, it's always some sort of zooming in, zooming out, choosing the boundaries, etc. And so what you need to remember is that your representation's goal isn't to be right, it's to be useful. And usefulness can come in the form of not just abstracting something, but potentially just doing boundary tests, kind of like what Ben was discussing. Like there are cases where you can just say, well, here's a worst case scenario analysis, or here's a, you know, construct that you use to run a test to answer a question. And so it's totally okay to not represent something even in the fullest fidelity that you understand if that extra detail is not actually helping answer the question at hand. And so that's just a quick check, is always use the simplest model that's sufficient for the questions you're asking. Ideally, you know, there'll be some complexity, some interconnections. That's why you're modeling, but you don't have to add complexity just because you can.
Great.
Oh, can I throw in one other thing that might be really helpful for folks getting started? Yeah, so it's interesting. So when we talk about boundaries, you know, one way to think about that is in terms of, you know, the boundaries of a variable, right? But I think that a lot that would be thinking that could lead some people a little bit astray. And the way I think about it is boundaries around, you know, something that you're studying as a container, right? So in that way, you're looking at the interactions in and out of some kind of subsystem, and that basically allows you to you know, basically chunk the system that you're studying more readily, rather than looking at I mean, obviously you have to look at boundaries of individual variables, but looking at, you know, boundaries of chunks of stuff is good.
Subsystems.
Yeah.
Great. Thanks, Brendan. Yeah, it's great having all this discussion come out. I think, yeah, let's move on to the next question. So Markus, this one's for you.
So the question is, what are the new features I would most want to see added to cadCAD next? I'm particularly excited about things we've been working on. Joshua Jodeci, like I mentioned, the developer, the main developer in cadCAD, has been working on a version that will have native support for distributed computing. So we're talking about performance gains. That will help us a lot when designing and modeling real large simulations, something we have been struggling with. Something that I would also like to see us as a community sort of build on, in terms of, it's not so much features but more of a sort of best practices, are ways around this until that's more broadly available, because again, it's distributed computing, right? It depends on cloud computing and things that not everyone has access to. So sort of standardizing the ways around performance bottlenecks with data streaming and data reading, data writing is also something I would like us to see explore a bit more.
Yeah, that's awesome. I think those are all features we're looking forward to seeing. I remember a few people in the group sort of not knowing how to deal with large data sets and storing that data and accessing it for things like CPU on a CPU versus GPU and RAM use and various other parameters. So yeah,
there's a lot of upside for people building out reference models that use different features from the data science aspect of the Python ecosystem. We built it in Python for a reason, to enable that, but up until this point, we've just done what we need to do. But as the number of users and the use cases grows, you'll see lots of opportunity for people to take advantage of those synergies, and I'm hoping to see that just sort of find its way into the community forums and whatnot, so that people don't have to reinvent the wheel with those interconnections with the data science tools in Python.
Yep. Awesome. Yeah, the community cadCAD discourse channel is a great place to go and discuss these things. Cool. This one's for you, Markus.
So the next question is about user interfaces to cadCAD other than Jupyter Notebooks that would allow non-technical users to explore model scenarios and get a feel for system dynamics. This is something that we have been working on at Block.Science. You can see the common stack models, for example, in the form of web apps, where you can just go to a website, set some of the parameters or some of the assumptions that you as a user of the model are inputting, and then in the background, a cadCAD simulation runs and returns the results, right? As graphs. There's a link in the comments there. The augmented bonding curve design. Everyone can check that out. And that's something that we've been working on for some clients as well at Block.Science. So at the end of the modeling phase, and once we run the experiments in a Jupyter Notebook, we might also develop a web app so that the user has a cleaner interface for them to sort of play around with the assumptions and have different and sort of look at the different possibilities and the different results that the simulation might yield. I think that's what we have for now. Yeah.
Okay. Following on.
The next question is, would there be easy to use templates for governance and economic systems people can just take and customize for their markets communities? And I surely expect that yes, that we will reach that point in time. We have some of that already with the sort of trying to build on that with the augmented bonding curve and the conviction voting mechanism, the models, the three-sided market models, things that are in the GitHub repos, like the cadCAD tutorials and the common stack repos. But the idea here is that one of the fundamental things about cadCAD, I think, is that once the whole community that uses cadCAD will be able to draw from these different projects that have been using cadCAD to model their own system and start to just pick those components up and use them as components in their own systems, right? Sort of like as plug and play as possible. Just get a lot of reusability from this design. We have been working on that. The common stack is a key player in that, and I hope the whole community starts building this as open source so that we can, again, like Zargan was saying, not have to reinvent the wheel every time.
Awesome. Yeah, there's some great resources on GitHub and all the various channels. I think we've got some links to them at the end as well. Here we go. This is the question.
So what cool things have been modeled in cadCAD, and what is the best way to find cadCAD models to fork and work with? Is there a central repository, or do we just search cadCAD on GitHub? Again, because this is open, we don't really have we can't really have a central repository. We do have some things in a main repository, like we have the tutorials and the reference models in the main cadCAD repo and the cadCAD tutorials repo that we control at Block.Science. There's I know of the token engineering repo that came out of the Diffusion Hackathon last week. There's the common stack GitHub, of course, that's going to add where you'll be able to find some of those models as well. And then I'm sure Molecule has some stuff that's open source or will be open source as well. So there's lots out there, and maybe we can put together as a community some kind of like a cadCAD awesome list. I know some people have started working on this already. Maybe we can build on top of that and start collecting that in a central repository. But ultimately, we'll have to search cadCAD on GitHub in order to have the full picture.
Awesome. Cool. Next question. So what design choices were you able to validate using cadCAD? I think so. When we started modeling the bonding curve that we're using, it's a very basic linear bonding curve. We started playing around with different hatch prices. At the time, we weren't calling them hatch prices, we were calling them Y shifts. And we noticed very interesting behavior based on these changes to the bonding curve that would result in sort of different returns for various users using the bonding interface. And we started using cadCAD to try and balance the incentives between contributors as well as meeting the success, meeting funding goals and ensuring campaign success. So yeah, we also managed to look at things like the sensitivity of incentive pools to whales. So users coming in with large amounts of collateral and sort of skewing our intended incentive behavior. And also recently started doing some modeling for another company called IXO, where we were looking at a sort of cross-blockchain liquidity interface and looking at and one of the things we looked at there was the stabilizing effect of arbitrage in things like Uniswap pools. And this is something that Markus was also working on, so it was great to see his model come out there and to be able to use some of that. And in general, I think just being able to, run a system through various parameter sweeps or Monte Carlo runs and seeing how robust the system is under different conditions. I think it really allows you to understand your system a lot better. I think that anyone, not just software developers and sort of people involved in the design of a system can benefit from sort of understanding the idea of complexity a bit more. And that's one of the things that we benefited from the most, was introducing this idea of systems engineering into our software development pipeline. So these are just a few of the outputs that we've sort of had with our cadCAD models. We were looking at various parameter sweeps here, looking at a basic linear bonding curve, a linear bonding curve with different hatch phase prices, and sort of doing a flat 100% collateralized distribution, various things that we've now gone on to implement in the Molecule contracts. We also looked at things like the way that Solidity's fixed point operations, how they affect variance and sensitivity to bonding curve parameters. So we've sort of modeled Unit 256 Solidity in Python/cadCAD. Here you can see a few of the sort of experiments that we ran for looking at the stability of a liquidity pool spot price. This is looking at the behaviors of various users of the system, whether they, and this is a very simplistic sort of two very simple behaviors, either buy and hold or seeking a return on investment. And something as simple as that can have a very big effect on the system, something that we didn't immediately have an intuition about. Okay, so this question was, for Molecule, what was the first or biggest revelation you had after simulating our system in cadCAD, and what's the biggest value add cadCAD has provided in the engineering design ecosystem? I think I've partially answered that already with the previous question. But yeah, I think just understanding complexity in a system, the interaction of different actors in a system, and answering questions that didn't have any sort of intuitive answer, even though sometimes you can make assumptions and think they do have an intuitive answer. So yeah, in general, cadCAD forced us to follow a more rigorous systems design process that everyone can benefit from, and that we missed in the typical agile software development mindset and process, where you creating a user-facing product. Now you've got, basic microeconomic systems that you've now got to consider. And I think, there wasn't a huge barrier to entry before we started to see the benefits of cadCAD. So I think the takeaway from that is that, you know, when you start using cadCAD to model your system, you mustn't be overwhelmed and try to overcomplicate things. You can start small and immediately see benefits in, you know, parameterizing pieces of your system. And, you know, start with a simple question, try answer it, and build your model up from there.
One thing that connects with what you're saying is to actually think of the system as having its own requirements. This is sort of almost like thinking of the whole system as a user. Like there are the users, which are the individuals, possibly multiple kinds of users, because they're often multi-stakeholder ecosystems. But what you end up doing when you bring the systems engineering thinking in is to ask what requirements the system has of itself. And so one of the ways it doesn't break the sort of existing product design paradigms is that it's able to be reasoned about in terms of those requirements, but now you're asking and answering questions about whether the system meets basically self-referential requirements. Maybe that's a little complex for people, but like it turns out we found it's a really effective way to communicate this, like, okay, yeah, your stakeholders all have their requirements, but what is it about the system that the system needs to have be true that aren't necessarily defined in terms of the users themselves?
Mm-hmm. Definitely. And I think something else as well is once you put your system into production, or when you get data outputs from a cadCAD model, those do in effect create an agile development loop where you take that data output and improve your model, or you take the feedback from users or the behavior of users and you can feed that into your model as well. Okay, I think, yeah, now it's open to further discussion. I know we've had discussion throughout the call, so if there are any specific questions or people who want to add a comment, now's the time. I think we can also look at the chat. I think we've been slowly answering those questions as we go along.
Yeah, I had a question.
Go for it.
Yeah, just a simple one. If you could, is there, it was asked, but maybe I'll ask in a different way. If you could post a, you know, basically a quick start for both of the systems, you know, just of the URL links where to get started, that would be great.
So, yeah, I think if Markus or Michael have a better comment on that, otherwise we've got these links as well.
Yeah, I think that the community is the place to start. I mean, all the discussion happens there, and there's a lot of introductory topics in there that can help newcomers.
The documentation for cadCAD is also reasonably good in GitHub, though. I recommend checking out community.cadcad.org first with a little bit of an effort towards, there's some articles that are a little bit more about concepts and some that are a little bit more about application. And once you sort of feel like it makes sense, you can either drive right into the tutorials that we have posted, which includes code mostly written by Markus, some videos created in collaboration with Andrew, and you know, ideally you just like clone those and start like mutating them and figuring out, getting a feel for what you can do.
Community.cadcad.org.
Yes, that's right.
Okay, great, thanks.
Yeah, the video tutorials were great and were where I started, and yeah, that helps you start experimenting with the actual, you know, implementation of cadCAD in a Python Jupyter Notebook.
There's also a pretty cool sort of overview of a power systems use case for it's with a company or entity called Freelio, which is I don't know if you've met Shebnam. She's sometimes in these calls. Her team has made a pretty detailed use case involving sort of community ownership of a local solar like array combined with a battery called a solar tainer. And I know they've published some writing about the use case. There's also code because we used it as the launch point for the hackathon. And I think as soon as Colin, who's on their team, is ready to share his code, that'll actually be a really good starting point. You might even be able to see it in some of the code on the community, the token engineering community GitHub, because several projects who worked at the hackathon like either forked or used some of Colin's code as a starting point. So I actually think that's a pretty good case, mostly because it's got the descriptive sort of almost business analysis first, and then it dives into his system model.
That was Freelio, F-R-E-E.
3 E's.
Ben, do you think we could pull up those diagrams in slides 10, 11?
Yeah.
I hope refreshing doesn't break your presentation. But.
No problem. Cool, I've got them up. I'm just going to share it quick. Okay, can you see that?
Yes. Okay. So that's the kind of diagramming I was talking about in the first 2 questions, where we sort of start describing the system in terms of what are the state variables that describe it. So in this case, there you see the state variables as those cylinders, sort of database like figures there, the components, like the ARC tokens in the purple top flow, and then we have the mechanisms of the system as those orange pink diamonds there that sort of describe, well, when are those state variables updated, right? What are the mechanisms, what are the interfaces that we provide for users or any external agent that interacts with the system that that results in a change to those state variables. And then the clouds there sort of indicate the boundaries of your system, right? So where things are coming from or where things are being created or destroyed, and we no longer keep track of them because we're not concerned with them. That's the kind of thing where, again, going back to Brendan's point about the interactions giving rise to complexity, and again talking about the black models or digging deeper and modeling the system in more detail. This is the kind of place where you might be interested in tracking, for example, ether balances of different subpopulations of those agents, instead of just not caring about it as it is in this diagram here, right? All the ether outside of the ether in the system goes to those clouds there. So we're not keeping track of them, but maybe we want, in some cases, we want to dig deeper and start modeling that in more detail. So once we have that covered, we move to the next slide, where we have the differential specification diagram, where we have in the middle part there the same state variables that we had in the previous diagram, and then on the second, that's the third row, and then on the second row we have the mechanisms that update those state variables, right? Each one of those are mechanisms that are either triggered by external policies, external processes, like environmental processes in the yellow triangles there, and then the pink diamonds are user behavior policies that also trigger the mechanism. So you have some kind of user logic that reads from the state variables and decides to take an action and trigger one of the mechanisms. And you have in the green pentagon there, you have internal system policies that sort of update the system. It's the system itself updating its own state based on some policy defined by the designer. And then in the bottom row, you have the performance indicator, the metrics that will help you make your decisions as a system modeler, as a system designer, that are derived from the state variables of the systems, right? So you'll be looking at some metrics, maybe profitability, revenue, or market share, or anything that's important to you when you're comparing two different versions or variations of your system. And then from there we start coding. Basically, each one of those components in the top row become a policy function in cadCAD. Each one of the arrows connecting the mechanisms to the state variables are state update functions. And after everything is run, we start doing the analysis to derive the metrics from the state variables.
Yeah, these diagrams are great. What tool do you use to draw them?
We're using Lucidchart internally at Block.Science, but again, it can be done with most of the tools out there. I've seen some interesting work with what's Microsoft new tool, Miro, I think. Something we're doing.
The first version is usually on a whiteboard or a piece of paper. It can be super low tech.
One paper.
Yeah.
Pen and paper, man. Going old school. Though to some ways, like I liken it to making a circuit diagram. So like once you have a pretty good idea of what you're doing, you're able to sort of sketch out the circuit before you go to build it. And then you could imagine that either writing a simulation of a circuit system or implementing a circuit system, it really helps to have a drawing of it first.
Definitely, and I think that's just one of those, it's just another thing that using cadCAD has kind of introduced into our design flows, you know, first creating a diagram, first working on paper, you know, it's things that you sometimes forget to do. Yeah, great process. Cool, I think that's, we've been going for almost 45 minutes now, I think.
There's a bonus question that just popped up in the chat there from Paul. How do you envision machine learning or AI to interact with cadCAD simulations to optimize parameters and behaviors?
Do you mind if I do this one?
Yeah, go for it.
Cool. I don't want to like jump the queue, but so in terms of those are two separate questions in some ways. So when it comes to using it to optimize parameters, you have to be really careful about the word optimize over the word tune, because in reality, optimization is inherently fragile because it tends to mean over optimizing for what you've observed so far at the cost of what hasn't happened yet. So most of the time when we use data to create as many stochastic processes, or like we learn process models and then run Monte Carlo experiments with many different realizations of the same processes. And that's actually already an ML technique because it's using a model of a stochastic process, data, fitting the stochastic process, using the stochastic process as a driver. Now, if you want to take it from there to sort of the next level of optimization on the parameter space front, you can imagine running big complex simulations with lots and lots of different parameter sweeps, and then using machine learning techniques to detect the sort of precursors to phase shifts and start to really uncover complex sort of dynamical properties. This is something we haven't done yet for the reason that the computational cost of running these kinds of tests is still pretty prohibitive. It's part of the reason we're working on our distributed systems implementation. But even with that, you're talking about running a very large number of experiments under a wide range of conditions, and then using machine learning to essentially detect which sort of parameter ranges and sets or compositions, so multiple sort of multi-parameter sweeps, giving you a sense of which combinations of parameters work well. And while that will work quite well as an AI application, it's always going to cost a lot of computation. And then on the behavior side, this is one of the more common discussions, and this is where you start to look at learning agents. So reinforcement learning is basically just a form of optimal control combined with neural networks. It's relatively common at this point. You would have to basically describe a set of objectives for the agents and then allow them to learn to behave relative to each other and relative to the system using what is essentially a self-training strategy. And that's actually not a crazy leap either, because it's already built in Python. You have access to any of the reinforcement learning tools that are there. We've messed around a little bit with TensorFlow, but we haven't really prioritized building out models in that direction, because we've mostly worked on failure mode testing as opposed to, the strategies that are going to emerge from reinforcement learning, in part because we haven't found that reinforcement learning agents, at least I haven't found, are actually good representations of real behavior. More likely, it makes sense that you can just determine what the worst case scenarios are and actually stress test the system by just directly designing the agents to attack the system. But that isn't saying one shouldn't or couldn't build RL agents in cadCAD, because actually it would be really cool to see someone take that direction. And I'm done, but that's a big question.
Awesome answer.
Who was speaking?
Oh, that was Michael.
Oh, Michael, great. Yeah, I'll just add. I guess the other thing to consider is the the layering of the system and the granularity that you're looking at. Hierarchies of layers of things, and in terms of optimization, it's kind of like the trade-off of which part and which subsystem are you going to, we don't want to say optimize because of what was just said, tune, right? So it's kind of like this stretching and pulling, right? You're going to look at one part and you might be tuning that up, but then you're knocking something else out of whack. So it's it's tricky in terms of approaching and doing all of this modeling concurrently with how you design your system. Like, thinking about it is not separate from your actual system design.
Get a little second order cybernetics in there. So
I hope that helped. I hope that helped and didn't make things more confusing.
No, I'm just saying, so for people's reference, the idea that your design of the system is part of the system you're designing is the central tenet of second order cybernetics, which is kind of came up around in the 70s. You can read about it. It's sort of motivated a variety of researchers that were working on human systems after that. Won't go down the rabbit hole, but it's an important concept, though it can be a little bit complex. So I'm kind of pegging it with, if you want to read more about the idea, second order cybernetics is the thing to Google.
I feel like this discussion is going to open a lot of rabbit holes after this.
That's the idea, right?
That's
Yep.
the idea.
So we have a bonus question number 2. Does somebody want to field it?
I'll read it off for you guys. How could real-world data from field tests like community currencies launched by Will Ruddick and grassroots economics in Kenya be fed into the cadCAD model to determine whether simulated agent data matches real-world behavior?
I guess I can answer again if you guys like, or I can leave it to, I feel bad because I wasn't, I'm not the AMA-er, so.
Oh, I think it's great to have you on the call, and it's awesome that we're getting such great questions and such interesting discussion towards the end as well.
Well, so in this case, I think that the key here is, Go ahead.
Oh, sorry. I just want to say a quick thank you as well to Ben and Marcus as well for all of the questions so far. It's been really great on the call. But yeah, happy to pass it over to you now.
So in the case of when you have real world data, it makes a lot of sense to use the data as the main driver for agent models. So you wouldn't necessarily ask the question of, did my agents match real world behavior, so much as you would transition from largely theoretical models of behavior in the direction of more data-driven ones. And there's a sort of continuum from, you know, purely theoretical, sort of here's some heuristics from behavioral economics, to the, like, we talked a bit about reinforcement learning agents and sort of optimal or even bounded rational optimal type agents. But once you start to get data, you will generally use that data to fit some models. And so you might want to do exploratory data analysis first, kind of get a feel for the pattern, construct a model that's pretty representative, then try to use the data to fit that model, and then actually use the policy models of the agent. So again, you're not fitting their exact behavior, you're looking to fit their policy. So given the state of the system and maybe some parameters or characteristics of the agent, how does that agent respond and act? And so you get an input-output operator, much like all of our other decision systems, that say, here's what I've observed and what I know, and as a result of my own private, preferences, priorities, norms, etc., I will do this thing, and you can actually fit or learn those models from data. So it's a nice mix between, like, theory, usually on the behavioral economic side of things, with the data to sort of tune the parameters.
Can I throw something in at that juncture?
Of course.
Yeah, so I think that's a really interesting way of looking at it. And to that, I'll add, what comes to mind is an example, like, say, because the question earlier was about, social dynamics and what do you, or how do you use these kinds of systems to actually make change? So say you wanted to actually, do something where you're going to, get a bunch of people to clean up Boston, and do something like that. Well, you can model from a parameter base, like count the number of soda cans that are picked up, right? But the point said, which is really, really fascinating here, is what happens at the design of at the policy level, right? So if you look at that kind of system as a policy, right? The policy could be like, okay, we want to clean up Boston and we want to do it in, like 3 days, and we want to collect 10 tons of trash, and we don't want to have any, bubblegum wrappers on the street, So looking at, how these things are designed at a policy level, I think is a really good, not just granularity, but it's a very interesting design model or method, right? Because a policy is actually not so much in a implementation, right? But it certainly can be, right? But if you think about your design of your system at this policy level, the policy level is almost like an interface, right, between your implementation and your modeling, right? So you kind of have this, by intuitively thinking about things at the policy level, and how you design an implementation of a policy goes both ways. It goes towards system design, but also it goes towards basically modeling.
I got a figure for you guys. If you don't mind me sharing my screen, I'll both support and elucidate that with something from a paper that I'm writing with Sherman. She's many of you know her. She's the director of the Vienna Crypto Economics Institute. So this is a diagram that, with great pain, we extracted from our research. I don't know if you guys can see it. We have a micro, meso, and macro level, and we have a bunch of different perspectives on the same core concepts. But what we're basically talking about right now is the difference between sort of the goal setting, the measuring of the goal outcomes, and the actual implementation of the incentives. And when we see these different columns, we're actually talking about these same concepts, but maybe from the perspective of someone who's thinking about economics, they're going to be thinking about measuring these global outcomes, and the policy setting is the institutional dynamics, the institutional economics, and the actual micro foundations are, at least in the crypto economic setting, these protocols that are implementing certain incentives, certain outcomes. And when we view this from the design perspective, what we're really talking about is sort of the performance metrics that are measurable over the system versus the targets for those metrics versus the properties that we actually assert when we, design and implement, we actually implement our design. So I don't know if that is helpful. Hopefully it's not making things more confusing. If it is, please tell me so I can change it before we submit the paper for publication. But we are working really hard to try to understand how these layers interact with each other and really tease out this meso layer, which is representative of this sort of goal setting that informs the implementation, because then the implementation has the effect of the observed outcomes, and the observed outcomes in turn affect future policy.
I think that's a very useful table or idea. Looks very cool.
So I'm going to stop sharing it now. But it actually bore a lot of similarity with what Brendan was saying. And I thought it would be, worth bringing up that this, in fact, this interscale feedback is something that I think throws a lot of people for a loop, because we're setting policies, implementing through low-level protocol or incentives or mechanism designs, but then we actually have higher level goals, which we then observe and influence policy. So you actually have a feedback loop that goes from the middle down to the top, and then from the top down to the middle. And without the teasing it out a bit, it can be hard to see the relationships between your decisions about what to incentivize, the implementations of those incentives, the effective outcomes, and so on.
That was awesome.
Great. Thanks, Michael and Brendan. Really appreciate the additional inputs to the session. I think it's probably heading towards supper time now. So I don't know if there's any more closing comments. Otherwise, we'll have to organize another one of these sessions soon.
I think there's one more bonus question if somebody wants to field it, and then we call it. I'm watching the chat.
Yeah, that's from Cameron. He's asked, do you expect the emerging field of research from cadCAD's application to be axiomatic or cataloged? In other words, if there was a singular collection of knowledge as a result of this collaboration, would it be a set of axioms or theorems, or a catalog of related phenomena and measures? I think, Michael, you're welcome to take this on, or Brendan, or whoever else.
I'm happy to. I'm going to answer actually that I don't actually think I would approach it as either a set of theorems and axioms or as phenomena and measures. I actually view it as more, I don't know if this is the right thing, but like, I think of it very epistemologically. So I view cadCAD as a way of merging a sort of theoretical basis, which is axiomatic and theorem-like, with a computational sort of experimental process with the observation. So each one of those things, the theory, the computational experiments, and the empiricism, provide a unique perspective on the phenomena of interest, and that the main output is actually the ability to marry the three into a multi-perspective view on the systems that leads to sort of more predictable, more useful outputs for people. And so the actual outputs for people, whatever it is that the design goals are, is the actual main goal. So it's almost like, as an engineer, I'm like, we succeed when we make the things people need and the people use those things. I don't know, is that helpful, Cameron? Yeah, I like that. He says a mesoscale bridge.
Nice analogy. Cool.
All right, I'm happy to close things up here, I think. I just wanted to say again a big thank you to Ben and to Markus and to Michael and to everyone as well that participated in the discussion. I think that this was a really great session. If you do want to continue the conversation, you're also welcome to pick it up again in the Molecule Telegram. I'll post the link now, or on Twitter, or via the cadCAD forum. But yeah, thank you so much everyone for joining.
Yeah, that was great. Thanks.
Thanks everyone at Molecule for organizing this. Have a blast.
Cheers, everyone. Have a good evening.